Moisture transfer. Controlling moisture flow in a building has significant impacts on occupant health and safety, comfort, building durability, and energy efficiency. Building science is concerned with two main forms of moisture flow: liquid and vapor. Liquid water moves as bulk water and capillary action. Water vapor moves through air leakage and diffusion. Bulk moisture movement or liquid flow has the potential to be extremely damaging to the buildings. Typically thought of as rain or snow, bulk moisture movement also includes flowing groundwater. So whenever you ano, you're planning to build a structure, you have to consider also the flowing groundwater and other factors that may affect the strength of your building, like um, yung mga water na pwedeng pumasok sa building na makaka-destroy nito. Three conditions are required to allow bulk moisture flow into a building. First condition is a source of water. Syempre, hindi naman mapapasukan yung building mo kung walang source of water. Pangalawa is a hole in the building envelope, yung mga loopholes, mga errors na napabayaan. Yan, pwede yun pagpasukan ng mga water. A driving force, example are gravity, capillary action, or wind. So, what is a capillary action? Let's talk about it. A capillary action refers to the ability of water to travel up against the pull of gravity through a porous material. One common example of this action is water wicking up through a paper towel. Although not commonly as serious as bulk water movement, capillary forces are both powerful and difficult to detect, since they often work in the dark of a building crawl space, causing significant damage to building without occupants' knowledge. So yung capillary action, imagine having a paper towel and then basain mo yung dulo na part ng paper towel, 'di ba yung water nagro-rise pataas. This is because of the pull of gravity through a porous material. So ganun din yung nangyayari sa capillary action. Rainwater striking the side of the house will run down the siding to the edge. Capillary forces can then draw the bead of water up and behind the siding, thus wetting the backside of the siding. Obviously, such forms of capillary can be hard to observe until serious damage has been already occurred. So, hindi mo siya madadiagnose agad-agad, not unless visible na yung damage. Capillary action can be best controlled by providing a capillary break, such as plastic, metal, damp-proofing compound, or another impermeable material, or by leaving air spaces that are too large for capillary to occur. For example, installing a seal between the masonry foundation and wood. And any wood structure is essential to protect the wood. The grade is sloped to drain water away from the foundation. Damp-proofing limits moisture migration from the soil into the concrete wall. Any water up against the foundation wall will drain down the free, draining backfill and out the perimeter drain at the footing. Capillary break and foundation wall. Capillary break in between foundation wall and seal plate prevents moisture from migrating from the concrete to the wood structure.
Air-transported moisture. Air-transported moisture, in the form of water vapor being transported by air, can get into or out of buildings. Both uncontrolled pressure sources such as wind or stack effect and controlled sources such as fans and air handlers can move significant amounts of moist air through a building's envelope. Leaky ductwork can cause moisture problems by not only increasing the amount of infiltration, but by drawing air in from the humid crawl space of basement areas. As this humid air travels through a building, the moisture in it may condense on any surface whose temperature is below the dew point. The amount of condensation that forms is dependent upon several factors: temperature of condensing surfaces, the relative humidity, and the speed of the air moving across the condensing surface. Colder surfaces, like windows and poorly insulated walls, condense moisture more. There are several ways to decrease the negative effects of air-transported moisture. The best defense is to keep moist air out of building through effective sealing against infiltration or exfiltration, sealing the ductwork, and pressure balancing the HVAC system. Proper use of exhaust fans in all bathrooms and kitchens helps to remove moisture-rich indoor air at its source, preventing cold spots through adequate insulation. Heating and air movement removes potential sites for condensation. Vapor diffusion. The movement of moisture from areas of high vapor pressure to areas of low vapor pressure. Even without leaks, small amount of moisture in the form of water vapor can pass directly through a building's envelope via a process called diffusion. Vapor diffusion from a damp or wet basement or crawl space into the living space can significantly increase the moisture levels inside the home. So this is the diagram of how diffusion works from higher dew point temperature to low dew point temperature where condensation occurs. Two things to determine the amount of vapor diffusion that occurs in a building. Number one, the driving force that pushes it, known as the vapor pressure differential, and the permeability of the material through which the vapor is passing. Most materials, even sheet glass, are unable to completely stop vapor diffusion, thus calling something a vapor barrier. It's not quite correct since it doesn't stop vapor completely. The current trend in building science is to refer to materials as vapor retarders, meaning that while they slow down the movement of water vapor, they do not completely halt the process. Materials that significantly slow down the vapor diffusion process are said to have low permeability or simply low perm. Typical building codes classify vapor retarders as Class 1, impermeable vapor retarders, rated at 0.1 perms or less. Sheet polyethylene, bisqueen, or unperforated aluminum foil, or FSK, are Class 1 vapor retarders. Class 2, semi-impermeable vapor retarders, rated greater than 0.1 perms and less than or equal to 1.0 perms. The craft facing on butts qualify as Class 2 vapor retarders. Class 3, semi-impermeable vapor retarders, rated greater than 1.0 perms and less than or equal to 10 perms, such as plywood, OSB latex, or enamel paints, classify as Class 3 vapor retarders.